Hey everyone, it's time to do our very last section for chapter 6, which is section 610. Today we're going to learn how to solve rational equations. They're just equations that contain rational expressions. Here we go. So, there are some steps. When you're solving rational equations, you have to check your answers because it is very common for answers to have what are called excluded values. And so I'll show you how to do that as we progress through the lesson. But just remember, whenever you solve a rational equation, you must check for these excluded values every single time. So if you want steps, here are our steps. We're going to find an LCD and we're going to multiply every term by the LCD, not top and bottom. It's not like what we were doing yesterday. Today we have an equation. We can do whatever we want as long as we do it to both sides of the equation. So as long as we do it to every term. Then we're going to cancel. All denominators are going to cancel out, and we're going to be left with a typical equation that we have solved in the past, and we're going to solve it, and then we're going to check for our excluded values. So for this first one, our LCD is x minus 1. So I'm going to start by multiplying both sides of my equation by x minus 1. If I remember, you don't have to do top and bottom. It's an equation. As long as I multiply times both sides, it's mathematically just fine. And look what happens. When I multiply this side by x minus 1, it cancels with my denominator. And when I multiply this side by x minus 1, it cancels with my denominator. And I'm left with just the equation x squared plus 2x plus 2 equals 2x plus 3. How do I solve this? We get everything on one side, set it equal to 0, and then we'll have a quadratic to solve. So I'm going to subtract a 2x, and I'm going to subtract a 3. When I subtract the 2x's are gone. Goodbye. Poof. I have 2 minus 3, which just turns into an x squared minus 1. This I can solve by square roots. Since there's no middle term, I could just say, hey, x squared equals 1. Square root both sides, put a plus or minus, and x equals plus or minus the square root of 1, which is 1. All right, so I think I'm done, except I have to check my domain restrictions. Based on the original problem, I had a domain that x cannot equal 1, which means positive 1 cannot be a solution to this equation. So my final answer is only negative 1. It cannot be 1 because 1 would cause me to divide by 0. If it happens in any term, you cannot include it as a solution. Okay, so for this next example, our LCD is x plus 1. So I'm going to multiply both sides by x plus 1. On the left side, the x plus 1's cancel. On the right, there's nothing to cancel, so I just have to distribute it out. So I'm left with 15 equals 3x plus 3. And now it's just a typical equation to solve. So I get 12 equals 3x, x equals 4. Now, if I look at my original problem, domain restriction was x cannot equal negative 1. That's okay. My answer is not negative 1, so I'm good. X equals 4, and I'm fine. By the way, if you ever want to check your answer, what do? Put the 4 in for x and see if you have a true statement, right? 15 divided by 5 equals 3. Yes, it does. So the nice thing about solving equations is you can always check your answer. All right, for this next one, our LCD, this term on this side factors into x plus 2, x minus 2. So our LCD is x plus 2 times x minus 2. I am going to multiply both sides by the LCD. X plus 2, x minus 2, and on this side, x plus 2, x minus 2. On the left-hand side, everything cancels. On the right, the x minus 2's cancel. So let's write what we have left. On the left-hand side, all we have is the 8 times x minus 1, which I'm going to write as 8x minus 8. On the right, we have 4 times x plus 2, which I'm going to write as 4x plus 8. If I subtract a 4x and add an 8 and then divide by 4, I get x equals 4. Is that okay? Let's check. Based on these two denominators, we knew that x cannot equal 2 or negative 2. This is okay. So that's our solution. Whoa! What happens when we've got 3 terms? It's exactly the same. What I'm going to do first is just factor this term out. And lucky us, it factors into x minus 6, x minus 5. So our LCD is x minus 6 times x minus 5. Now I'm going to write this all out so you can see what's going on. So I'm going to multiply my first term I'm going to multiply the second term times the LCD. And I'm going to multiply my third term, the right-hand side, times the LCD. Every single term gets multiplied by the LCD because when you're multiplying by the LCD, you don't get to multiply it by terms like it's not you pick, it's whole sides, right? You have to multiply the whole side on both sides or you're not doing it properly. So let's go ahead and do some canceling. So this first term, x minus 6's are gone. Second term, x minus 5's are gone. Right-hand side, the whole LCD cancels. So if we write what's left, whoops, I don't want to put an equal sign. We have x minus 5 plus, there's an x here, x times x minus 6 equals everything canceled on the right-hand side. We're just left with 1. So we have x minus 5 plus x squared minus 6x equals 1. And if we combine like terms, get everything in descending order, we get x squared minus 5x minus 6 equals 1. So if I factor, equals 0. Sorry. 0. There we go. Okay, so now if I factor, I get x minus 6x plus 1. So my two solutions are 6 and negative 1. However, based on our original denominator, we know that x cannot equal 5 or 6, which means x equals 6 is an extraneous solution. So our only solution is x equals negative 1. All right, our last problem here. So we have an x squared minus 8. X squared minus 8, it doesn't factor nicely. You can do a difference of squares with the square root of 8, but let's just keep it x squared minus 8. Oop, I can't write LCD. Okay, LCD, we have x times x squared minus 8. So if I multiply my first term times x squared minus 8, and I multiply my other term by x times x squared minus 8. So on the left side, the x squared minus 8's cancel. On the right side, the x's cancel. And what am I left with? On the left, I have x squared. On the right, I have, if I distribute the 2x squared minus 16. All right, so let's get everything down to one side. So we have x squared minus 16 equals 0. So x squared equals 16, square root both sides, and you get x equals plus or minus 4. Our only domain restrictions were that x cannot equal plus or minus the square root of 8, which is 2 root 2, or 0, which means Both of these are correct. And of course, you can substitute